We are here in Sesibwa Bridge, and here with me are my colleagues from the Department of Agricultural Production, and we are here with our students from different programs.
Good morning, my name is Gerigon Olupot from the Department of Agricultural Production, Makerere University. We have brought the students of land use, agricultural land use and management, among others. One of the activities normally in the third year is that we bring these students out in the field to appreciate what is happening in the field within the context of land use and management, the impacts that are being created, positive and negative. So we are in this is Sesibwa River, to highlight the impact of upstream activities on the quality of the water. We actually unlucky that there was a serious dredging that took place after we had gone for the reconnaissance. So this water now looks, it was not like this, it looks a bit clear. It was completely dark like charcoal. What do we know about the properties of water that is considered clean? It's colorless, it is odorless, it is tasteless. I'm sure if we tested this water here, if it were possible, it would have a taste. We can now not get the smell, but it was there very strong. And then also the color, you can see that it is still not much as it has improved, but it is still bad. So at this level of degradation, the fish need light to feed, to breed, and also perform other functions. The penetration distance for the light will depend on the clarity of the what? Of the water. Now the color of this water, what happens to the soil when there is not much organic matter? On an open water body is an indication that the nutrient load is building and the biomass, the sediment is building, and within a short period of time this will transition into a seasonal wetland and eventually a dry land. If you look at the stages of growth and maturity of a water body, it starts as an open, clean water body, no vegetation, no what, and then you start seeing traces of plants appearing, and now what you are seeing is a mass of what? Plants. These are papyrus, for those who don't know, those ones with nice heads, that is papyrus, and its role is to what? Purify the water. As long as you don't disturb that vegetation, that is what it will do. But the fact is, it is producing biomass that is decomposing, adding to sediment, organic matter, and eventual death of the water. The challenge is when you come to harvest that biomass and you accelerate the speed at which the water passes, and eventually that will not save the wetland from drying, because it shouldn't have come to this in the first place. This was a giant open water body which feeds part of the water, the Victoria Nile, all the way to Mediterranean Sea. So we have a responsibility as upstream, as an upstream state towards the lower riparian states, in making sure that the water gets to those other places in the correct volume and the correct quality. So this is what I hope we have picked samples here.
When you look at the color of the water, usually it's not easy to assess what kind of pollution has taken place in the water without certain kind of measurements, okay? And what kind of measurements you need to be able to know whether the quality of this water has deteriorated?
Lord,
there are certain visual observations that you can actually use to speculate whether the water has actually been polluted, all right? But also very important for you to know that there's a very strong relationship between the turbidity and what was talking about the BOD, and also the light penetration. How far does light actually get into the water? And that actually makes a very important influence on the survival of other organisms which are down, and also the sustenance of basically that water body surface. So it's very important for you to be thinking very broadly, okay, how also this catchment is actually connected to what he has actually spoken about the Kyoga and also the other parts of the bigger catchment that actually this Sezibwa flows into. All right. When you also look at this place, I hope you appreciated what is happening drastically at the margins. The
activities at the fringes.
We don't want to pinpoint that it's the sugar refineries and so on, you know, because we don't have yet evidence of results from analysis of water quality. But you must also understand that this catchment, also all these particular swamp can also be affected by the neighboring agricultural activities, okay, that are happening around. You will even appreciate some bit of cultivation that is taking place at the margins of this swamp. So don't look at only one main point that you may need to address or think about how the dumping of the waste from the sugar refinery should be handled, but there are other points of pollution.
In other words, Isaac is drawing our attention to point and non-point sources of what? Pollution. Definitely, normally there should be the standing out culprit that the factory discharges loads and loads of cubic meters of wastewater into this water body untreated. So what we would wish to do is locate another water body not directly influenced by such activities, and then we would see if it is the same. Then we can say, okay, because of this other. But what I wanted you to get from the fringes, what major crop did you see as you were coming to enter this?
Sugarcane.
Sugarcane. And it is the same sugarcane which goes the other side. So those are the among the activities that are threatening our water bodies.
Yeah, thank you so much for joining. This is the river that probably most of you should have known was at one point a point for contention when the Kabaka wanted to cross over, and there was some bit of blockage here for him to go beyond this point, and that caused a lot of riots in the Uganda region. But you see, in the past, we know these rivers were very instrumental in identifying boundaries for different, you know, big kingdoms and organizations, basically kingdoms in the past. So that's very, very important. And of course, River Sezibwa, you can see, is one of the big wetland, wetland system. It's a very huge wetland system, and you can only appreciate actually the size when you come here. It's really one of the biggest around we have in the country. But of course, within this wetland system, you can observe that actually it's surrounded by very interesting, fragile ecosystems. Actually, it's not very far from Mavira Forest. If you go to an aerial view of the whole of this landscape properly, realize that is between the Mavira Forest is within it. Then you realize there is also Lake Victoria just across this. And then you also realize that there is the Victoria Nile, which he has mentioned. That's why I think it is that's the outlet for the water. And then, of course, not far from here, we know we have a big Kampala city, not far from here, where we know there are a lot of issues in terms of population and settlements and rapid growth and industrialization. So we are in a fragile ecosystem within the Lake Victoria catchment, Lake Victoria Water Management Zone, Lake Victoria Water Management Zone. So when we talk about Lake Victoria Water Management Zone, those who are not doing issues on water, the government of Uganda has got what we call water management zones across the country, and they have deployed different actors in these water management zones. Actually, we have offices now in Lake Albert. We have Victoria, we have Kyoga, we have the Upper Nile. There are about 5. So we have offices in all those centers. The idea is to bring services to the people and also manage a water system in an integrated way. We normally actually say, please keep the water sources and preserve the environment. Why? You see, if you destroy such an environment, and you put sugarcane, and you put yams, and you put other kind of things, what's going to happen in the future is not good, because you need again water for irrigation from these water systems, these ecosystems. You need water from these environments. That's why we need to ensure that we keep the wetland from encroachment, from these threats, human threats. So if you look at this big catchment, if assuming we lose all this through a lot of encroachment, through agriculture activities, it's not good. Yet we have alternatives to use the other land outside, outline this environment. Now, why I'm trying to say this is we need to, when you conserve environment, the environment also feeds you. It's a simple logic. Now, if you destroy the environment also will also automatically destroy you soon. That's why you as experts now, you must be able to acknowledge the importance of such an ecosystem. Many things which I won't talk about. They are providing a lot of many ecosystem services. But for you as students, I think you'll be keen to understand to what level of degradation are we experiencing here in terms of water quality. And then you as a student should also be interested to see the larger context of River Sezibwa. Where is it coming from? And how has it been encroached? Like you guys who are here, you should be interested to look at satellite images even today before you sleep to see how actually the Sezibwa has been encroached. It's in its entirety. How has it been encroached? Is it reducing? Is the wetland reducing, or it is increasing? Okay? That will be your area of interest. The water issues, quality, we have already mentioned. Now, when you see water quality at this level, again, as a good student, you must explore. Where is this coming from? Where is it coming from? So we have tools that can help you to do that, to monitor this. Either engaging the community, participatory, to explore what's happening in this area. The community can give you information in terms of who is doing what, who is encroaching what. So if you move to these communities, you will know. Secondly, you can use these satellite images as well. The images will give you, if you take an image of 2000 and 2010 and 2020, you will see something happening in this catchment.
Pacific Ocean, Atlantic Ocean, Indian Ocean, this is salty water. The pH is above 9. And actually, as you go below the sea, the pH can go up to 0. I don't know whether you can imagine that. If you go in the sea level, the pH can go up to 0, and actually if you put your finger there, it can be cut. Yes, it is very acidic. What? Below the sea level at the bottom of the oceans. So we live in a very dangerous world. And God has created this world in such a way that we survive on only 25% of the Earth's surface, which is soil and rock covered. What you see here are the rocks, the soils, but there is also life down there. If you dig a soil profile pit, you see the parent materials. They are what we call aquifers and rocks. They are there, parent materials. So this is the system in which we survive. And so the challenge has been that the waters are not fresh, they are not used for production. Most of the water is tied up in ice. Some of it is salty. So most of the usable water is very limited. So water is a scarce resource. And that's why I like people who are doing integrated watershed management, because they are supposed to look at water and how it can help people survive in a given environment, what they call a watershed.
In the swamp they are growing maize, and maize does not do well in wetlands.
Yeah, so they probably didn't do soil survey and land evaluations. Any other observation?
Yes, I say where there was growing maize, millet was also grown there and it was doing well. So instead of growing maize in the swamp, maybe they could substitute it with millet.
You saw millet doing well?
Yeah.
And the maize was refusing to do well?
There is a
certain swamp in the middle. I'm not sure what the name of the area, but most of the swamp is being transformed into rice production, and there is also a lot of sugarcane production on the other side, right after the Kamuli town, in the middle there.
Line, sink line, antcline, sink line, but the depth decreases until you are coming to a flat area. To me, that is a good general observation. You have come from a water body which, had it not been because of pollution, is generally still like, it is still not so much disturbed. I would have expected to hear from you that along the way, because what we said there is that unattended to, they will become what?
It's okay.
Seasonal wetlands, transitioning into drylands. Haven't you seen where that has already happened along the way between the where we stopped and here? Yes. So why am I not hearing that? And then when you see acacia vegetation, what comes into your mind about the climate, the hydrology of the area? What comes to your mind? This is an area that receives low amount of rainfall with prolonged droughts, and the vegetation changes its adaptations to cope with the stress. So we have to know that we are actually in the cattle corridor of Uganda. Somebody from Isingiro, Mbarara, Kachumbala should have already seen that they are at home. For me, the first time I go to Isingiro, I felt like I was in Kachumbala because it has the characteristics of the what? The cattle corridor. Now the other important thing, if you look at you seeing something that looks like palm trees? Yes. That tree is the major dispersal organism is the elephants. So the other important thing you notice is that this area, maybe not so long ago, could have been a wildlife dominated area where elephants were players. So in light of those general observations, what is happening? I also expected to hear from you that you have crossed the longest river in the world.
Basically, the reason why I would bring in my kind of view is from the fact that when you are doing, if you are doing an assessment of this level, this is a national investment that was done here. The dam that you see here was a national level investment. Probably the benefit of this project here is not for this local community, right? It's not for this community. It was a huge investment at national level with millions of money poured here. But you see, in the process, because of this simple project which came here, the idea which came here in terms of a dam, it caused a lot of impacts. Not so. A range of impacts have been, derived from this development. And that's a very important point. Now, initially we never used to have this road here, those who don't know. We've been using, actually, I think a ferry somewhere to connect these districts, Kayunga and Kamuli, I think. I'm not from this side, but I know people have been using ferries and other means of connecting through this river Nile. So when this project came, look at it as a national investment. And of course, you may find that me, a farmer who has a small house here, even I'm not having the power or the electricity. Not so. However, there are those side effects which came with this project. Those are very, including the good road you can see, and also the jobs which came associated with this project. But also, because of that, there has been rapid land use changes on this, line of road. And these are issues which you guys who are doing kind of impact assessment, but also land use planning you could be interested in. Because such a project really, it means that even the planning may have to slightly adjust in terms of settlements, in terms of, setting up shops, health centers, because communities have been coming closer over the last few years because of this project. Many communities have come closer. The agricultural landscape has changed. You can see rapid development of agriculture here. So there has been rapid change. Now, for those who are doing land use planning, of course, you'd be interested to really know such kind of a project, how it could have affected the land use planning process in entirety. So the other thing you need also to know is in the planning process, land use planning, you know this already, that we normally have a goal. So you all know also the importance of the energy sector, those who do some bit of energy management at various levels. You know how important it is for a government to invest in such a huge hydropower system in form of the energy line of thinking. So when you set up such a system, of course, in terms of renewable energy, this is one of the renewable energy sources we have. Of course, there are many other dams that we know that are being set up, including Karuma, and many other mini dams across the country. Now, those who know what we are suffering or what we are going through as a country in terms of biomass, cutting down of trees, and when you cut down trees, you stimulate land use change and soil degradation and soil quality change, etc. Now, these projects are coming in as a measure somehow to minimize on the encroachment of these forests, and it has a direct benefit, not so, to those who are cutting trees and all these kind of things. So look at all those things in that kind of context, because again we are trying to conserve the environment, preserve the environment through such projects. And of course, these are renewable projects, although the cost of investment to make it can also accumulate what we call a high carbon footprint. The cost of making such a project, it can consume a lot of, it's a lot of carbon footprint in terms of when you estimate. Okay, so you look at that from that context. But of course, when also we have already discussed that there are a lot of changes in the soils here because of the heavy machinery and a huge project change here in terms of the investment which we see here. Now, as students, I think you must be interested in mainly this driving force, which is the dam, on many things here, including the soils. Many things changed. Okay, but also looking at it from the national level, what is changing? Yes, locally things have changed, but also nationally, what has changed because of this project? What is the contribution of this to the national grid?
An investment project or development project, you do what we call an environmental impact assessment, EIA. And the reason I've said speak is that I want us to move in that direction. So every time there is a development activity, we look at the positive and the negative impacts. And I don't know how far Dr. Rupert went on this, because quite often people concentrate on the biophysical impacts, say the trees are going to be lost, biodiversity will be lost, organic matter will be lost, but we forget the social impact. So social impact assessment is very important. In fact, NEMA always talks about social impact assessment for all these projects, and there are reports. Some of these reports are online. They are so detailed that if you are ready to follow those things, you might fail to implement any project, because there are many bad things that happen. For example, issues of land grabbing, people being displaced, people not being properly compensated according to the market rate of their land. And these are issues which cause challenges. Sometimes people even riot. I've seen people demonstrating against certain projects because of the social impact. Families are destabilized, people get displaced. So I don't know whether you talked about the social impact. It's a very big thing.
There is one who from Hoima, when they insisted they wanted land, they said, we shall take you to Karamoja.
See?
They wanted to give them money.
These are serious matters which can affect the economy, which can affect the cultures of the people, can affect the security of the country. It has a lot of implications. Politics of the country, because you can imagine if a project like this comes, maybe someone lost the constituency as an MP and he is bitterly campaigning against the Simba Dam. Maybe even sabotaging. At one time here there was a short circuit which, where this thing, the whole place there was a blackout. Maybe there was a subversive activity because of the social impacts I'm talking about. So you need to assess land use impact assessment in totality.
This is the Digital Road Training Center. It's the home of the Iowa State University Uganda program. This is our home. We acquired this place in 2015. We built it, started from 2016 November, and we occupied in 2018. We have the nutrition program there. You can say ready feeding a child, where we look at malnutrition, rehabilitation for young children from age 0 to 5 years. And we look also at lactating mothers. We also look at the pregnant mothers who are at risk. These are becoming anemic and having difficulty in their pregnancy. So
those are identified in the communities by the network facilitators and also the youth, the health team people, and also the clinics within the communities. And then they are required to us. Then we do our assessment and decide whether it is acute malnutrition or mild malnutrition. What we handle in the field is mild malnutrition.
Here we have a nutrition education center. This is one of the over 22 nutrition education centers. This is the Mother Nutrition Education Center. It was the first, started in 2010. The concept was rehabilitating malnourished children, severely malnourished, using local foods. And these foods include grain amaranth. It's dodo, certain type of dodo which grows, then you get the grain, we shall get the plants and the grains. Then maize, which is also locally grown. Then soybean millet. In that porridge we add silverfish, provide animal source protein, then sugar and milk. So the porridge makes up 7 components. This is what we feed to the mothers, the children. It's a supplementary feeding program. So the centers are currently 9 which are active. We closed the 14 because of funds. They go to another area. We don't stay there. We just reallocate the funds because our annual budget is fixed. We're supposed to operate 10 nutrition education centers, so we have to close one to open another one.
The point is, you have a program. Stop this regulation.
Okay, that's why I mentioned.
Yes. Then they stop this and then we
Thank you very
I say during family planning, everyone has come from cities, come here, they give so that is good. And you go ahead saying people we are trying it in the centers.
Mukulima pehakira abasinga bali muzimba libi naye mukulima kuno twali twagala okunyonyolemu katini mutubulidde nti nakyole tunyonemu neforeda bulungi naye ekibuzo kiriwo ntino bano abaana abamu Makerere basanyufu nnyo okulaba ntino waliwo bintu bingi ebyofunamu
okukola mulimu okulima n'olima ettaka n'ojjamu ky'ogyemu ate n'ojjamu kinenkola ekyo naye ffe ekibuzo ekitulina ekikulu nnyo bwe mufuna ettaka lino for example ofunyemu iikemu bakuwadde iikemu olime ekibuzo ekyembuuza mulitematomulomutya ekyokubiri nga mulifunye kale mulimye emutuwulidde wano.
I am Thomas Linda. I coordinate for service handling and washing, water sanitation and hygiene. So here, this is our field house, and we do a lot of things here. So first we handle grains from trained farmers. We have a number of agronomists led by Maureen. So they work with farmers in the field through all the good agricultural practices up to harvesting, and then we start with the post-harvest practices from which we do here. So first we do the inspection of grains from the farmers. Although they are trained, but there can be some kind of gaps. So we have set some parameters and we follow the East African Grain Council standards to either receive the grains or reject based on the quality parameters, including aflatoxin levels, the discolored grain, shriveled, and foreign matter content like remains of plants and secretons of insects. So then, so our standard is 14%. If the total defective grain is less than 14%, we accept. If it's more than that, we reject. Also, aflatoxin content has to be below 10 and below, following East African standard still. So when we accept the grains, we still undergo further cleaning, sorting, and then some minimal processing and even further drying. For example, if the moisture content is above 13, we dry more if they are not for immediate use, because the safe storage moisture content has to be not more than 13. If they are for immediate use, even if it is 15%, that is fine. Because most of the grains that harvest, the moisture content is around 18%, appropriate for harvesting. I don't consider it okay for harvesting. Service learners.
No, they are student innovations.
Service learners are students of Makerere University that come here to do internship. I myself am also from my service learner.
Of 2013.
2014. So I did food science and technology, and then a master's in public health. So here, this machine was made by our former service learner. Is now in the University of California doing a PhD. And the machine he made for his research is this, for undergraduate research. This is the machine he made and he funded it. So he went on to form a company, and this company is making this machine and is now making motorized. And also, I think I can call it an abrupt visit, because we were just told today morning to come in. We would have organized for you if we had enough time.
You post on social media?
Actually, those who saw newspaper, it's him who picked it.
You see? We were not live at campus, that's why you saw it. And this one is also the Grenaman thresher. It's a second prototype. This is first, this is second. So this is the husk. Instead of using a locomotor and metal, just put here and then it does this for us.
Sustainable source of income to be able to have the nutritious foods back at their homes rather than depending on the forage that they have been given, so that we don't have relapses and also not having the malnutrition cases in their homes as well. So we come up with projects for them to earn income. So we have the crafts making. They make items like this, the baskets. We have synthetic dyes. We also have natural dyes from plants. that they make within their community. Yeah, so we also make some items from the African fabric, like the bags, from the back cloth. We also make some hats here. We have soap making group. We do leather products where we have belts, we have sandals, we also have some bags here. We have bookmaking, we make exercise books, we make these crafts books, we make black books and any other. Then we also encourage them to diversify their income. We have Basket for a Goat project where we make sales and invest in livestock.
Request, they put the request, then she dispatches. So this outside is the
smells like food already.
Now this one is from the other boot room. When we wash the hands, we use the tissue to dry the hands.
Biodegradable waste for recycling. Now the plastics also have their own pathway, so those should be separated. What other? Don't you have glass?
Glass, all of them are heaped there, then they are sorted when the plastic people come to buy. Because there are those who buy glass and those who buy plastic. They are different markets.
So they are all placed
those
there.
scrap people.
They are all placed there. So MSc Soil Science, the improvements to that system, because we went through the different processes. Point of generation, where should the sorting start? That is the primary collection. Actually, that is for this institute. That is now the secondary collection side. Because I imagine
they are small ones.
The primaries are inside. Then from there they come there. Then from there now the tertiary pathway. So all those processes, when we talked about integration, they must be what? Integrated. Whether you are dealing with plastics, whether you are dealing with glass, whether you are dealing with the nuclear, whether you are dealing with mining, whether you are dealing with the market, there is generation of waste and therefore collection. All those, when you are talking about collection, the collection must be integrated through one coordinating body. Then it becomes easy for you to know who collects, who handles which aspect. That's what we talked about yesterday, integrating the goals of waste management or water issues, integrating the actors. Who are these? The different actors. Integrating the actions, what happens at which stage, integrating the processes. So you cannot run away from integration. For MSU, Integrated Watershed Management, you know what it means. So I want improvements to that system. So it is mixed with the biodegradables?
Yes, it's mixed there, the polythene. Then for things like metals, like glass, glass, broken glasses, then use the pads, those things with syringes, we have incinerator up down there for burning.
Shall we be able to visit it?
You are going to see the incinerator. Even those paper materials, we take them in the incinerator for burning.
What I was trying to labor in this plate, you press this neatly so that they don't, nothing should fall inside here.
You see what is there? I talked about not sorting. The buvela will still mix up with the general waste. So when it's full, we get it there. When there are many, we organize the transport to take them out. Facility manager here, you can't step in here without him knowing you're coming. So he is always here and he will talk us through all what you want to know about this place.
And I think I would like to maybe begin from the other side. We shall move from the other side, then so that we can go by process, step by step. See when we are going. and we have we harvest water, or we have sources of water, we have national water, we harvest from the roof, that is the roof harvesting. Then we do have the borehole water, which we pump. We have our borehole somewhere there, you shall see it. Then we do have also sources of power, about 3, the national grid, then the solar power, and the standby generator. So we shall move and begin from the other side.
Please be close to Charles so that we don't miss a word.
This is how we harvest from the roof. Wherever you see such kind of arrangement, you will see many of them. This is how we harvest our water here from the roof. So down on the ground there is a sieve. Then on top of that sieve there is also what? Layers of gravel, different layers. There is the big stones, then followed by the small stones. So we filtrate that water in such a kind, then it goes down, then it goes to the water river. There is a pipe which takes it to the river. You see those tanks down there when you reach there. So that's how we harvest from them. So that water is filtrated very well until it goes to the other side. And when it reaches the other side, there is a sandy filter which filters it and we pump it to the tanks. There are 4 tanks, the one for the national water, I mean for the harvested water, and then the one for the clean water. Because when it reaches there, it goes into 4 tanks, then from there it goes through the sand filter. From the sand filter, it is pumped and stored in the 4 tanks. That one we call it for the clean water. Yeah. So we shall not maybe waste up. We have 2 washing machines and 1 dryer. This one is a commercial washing machine. So mainly when you have clothes which are very hard and you have many, better use this one. Then the other one, the small one, for the light clothes. This is about 13 kilograms. The other one is 8 kilograms. This is just the dryer. But this can do both, even though we have dryer there. Today I want to show you the water purifier where we get water for drinking. So, as I told you, that water comes from the elevated tank to the facility. We have the facility here, so it's connected here. Then from here, after purification, it is stored. We have a small tank here which stores that water. When the tanker is dry, the other pump has cells and fill it. When it is full, that goes off. So this is the water feed. This is for the water pump. Coming here, you may find the pipes are contaminated, so we make sure it's again filtered before it goes to the elevated tank. Then from there it flows by gravity to the facilities, to the rooms. That's how we get it. This is our power house.
This because it is pumped. The running indicates that it's pumping.
So this bore it has 100 meters. Then the
8 or 7 meters.
Yeah.
Do you understand what the head is? Yes. It's unfortunate Isaac is not here. What happens to pressure with depth?
It increases.
When the depth increases, pressure does what? So that 87 is that pressure we are talking about, the burden. The physicist is also there.
You have said exactly
The
that.
diameter of the bore is 8.
80.
Not 80. Up to the tank, that is 70 meters. From here to the other black tank where it was 70.
Up or
To the black tank, that black tank where it was in.
so that 87 is to create that pressure for the water to be
go up.
pushed up.
You see? Those are the pipes. Like now, the one which comes from the other side is this one. Then this one is this one. Then the it reaches in this. This is the first point. This is just a manifold. Then we have 4 chambers here. One chamber, this one is bigger than the rest. And the rest, those 3 where you are sitting, is just liquid. The stuff remains in this big one. But this is a kind of a bioreactor whereby this stuff ends here, and then you find this one is lower than this one. The way they are designed. Yeah. No, it is lower.
Because the incinerator is supposed to turn this completely into ash.
I think she has not yet burnt her thing. Just broken.
Yeah. So it first fills up. So where is it loaded from here?
Yes.
Yeah.
So I'm still working on it. I've moved, I've traveled. Huh? I'm still working on it. I've traveled.
So when the liquid comes, the first 2 hands from here.
The cow here to celebrate.
Yes. Have one.
Here, it provides a very good buffer against polluting underground water sources, because first of all it has a very deep rooting system and it's very effective because the branching architecture of the roots of eucalyptus is very effective. It penetrates the soil pores, micro and macro pores, to the extent that everything bad can be easily pumped out. That's why we use eucalyptus in phytoremediation. For example, in Kirembe mines, we have the acid materials from the mines, and we are using eucalyptus grandis, and to clean the environment. But because of the property of first growth, so just to support what we are saying, this is correct. You have got the right species in the right place to do the right job.
Land use impact assessment, have you seen that this place was waterlogged, and one of the measures put in place to sort of drain it a bit was planting what? Eucalyptus. But Professor Twa is saying that in terms of efficiency of extracting either heavy metals and other toxins, it has a very efficient rooting system.
We have published
actually
papers about the efficiency of eucalyptus on cleaning the phytoremediation.
Actually, eucalyptus is one very cunning tree, and opportunistic.
Yes.
It will know where the strategy to adopt to grow its roots.
Exactly.
If the nutrients are deep, it will go deep down. If the nutrients are on the surface, it will explore the surface.
Itself.
Yeah. But now we also know that the effluent is discharged to the what? natural wetland. And you would imagine that downstream there are communities that depend on that water. So are we able to filter out the impacts, both the positive and negative of the kind of land uses that we are observing here?
We have written a project on nature-based solutions to clean the environment without necessarily putting money, just sensitizing the communities, then use these simple resources. Actually, the Danish government has given us 10 million kronas for the next 4 years.
Yes, good morning. My name is Gergon Olupot from the Department of Agricultural Production, Makerere University. We are here in Mpiringiti, Iowa State University Uganda Program Service Learning Center. We have brought the students of land use, agricultural land use and management, among others. Unfortunately, that program is being phased out, but one of the activities normally in the third year is that we bring these students out in the field to appreciate what is happening in the field within the context of land use and management, the impacts that are being created, positive and negative. Here now we have toured through how the institute manages solid waste, human waste. Down there we have been visiting a constructed wetland. But up here now, where you can see from the background our students, we are in the final stages of how the institute is managing the problem of water. There is rooftop water harvesting. They have also pump water from boreholes, and then they are also connected to the national grid. But from the interactions, the bulk of water use is from actually borehole and rainwater harvesting. Here where we are currently, when all the water is collected up there, it runs through the pipes into these tanks that you can see. And from these tanks, it is subjected to a series of sedimentation and filtration. And then these tanks are designed in such a way that there is water for general use in the lavatories, the washrooms, and all this. And then there is water for consumption. Water for consumption is pumped again for specialized purification. Up there, we have already visited the biofilter, and here now we have seen also the water getting into the system, the management of sewage down there. If you can, there are septic tanks there where the solid stuff is separated from the liquid stuff, and the liquid stuff flows through a series of sedimentation tanks, and then to the manhole covers into the natural wetland, where the purification is purely natural, by natural filtration by plants, papyrus and other vegetation, and then after which there is eucalyptus. The water, clean water, is then released to the environment, and these are the best practices we want the students to pick when they get into the communities. How do they organize what the communities are doing? We also have experimental sites for crops, different crops and best bet agronomic practices that we have visited up, and now from here we are heading into the communities that this center benefits. What practices are they able to pick from here and implement in their practices? We shall be in their own operations. We have a team of agronomists that are trained and recruited by this center to guide the communities. So I hope that you can pick a message from this. This is not the kind of program to be phased out as it is happening when issues of land use and management are getting very, very crucial in our communities, and globally issues of climate change, environmental degradation. We cannot be thinking of facing such important programs. This is among the last cohort of students before this program actually comes to a close, if no reconsideration is made to restore the program. Thank you very much for listening.
If this one is dry, the pump will sense this side and then it will go. When the other one is dry, the same thing. If it is full, it will sense and then the pump sense. So the floater switches which control the pump. This is the sun. Down to the pipe. The other one with the grapple and the final one.
So 2 types of sand here.
We have this one.
The gravel. And then the fine one.
So the gravel one, the one they first put there.
Yeah.
Then they put this one.
Yeah. So where do they put the sand?
Then for what is smelling, those big plastic, no, the black tanks are water tanks. Then these put down, and these you get from Nigeria.
The pigare, whatever waste, there is one system into the what? The receptor. And then it eases management and having each unit on its own. So you can't run away from integration.
Okay, we can go and see the other
My wife agrees.
Please, we are getting started at Mr. Elisha Kayabia's place.
I don't have a lot for you to see, but we have a number of things as stated there. We have crops, and we are doing crops and animal husbandry, and of course soil comes in. No problem in that. Here we have a number of, we have grasses here, we have which I've forgotten, but tebisiwa, era bwe zikula zirina mutawaana. Then we have ebisiwa, the common one. Is it food? We have for the animals. Now, this side for little bit. I just mix this here and here, then put in some, I put in this brand. Let's have my measurement there. Then after that we cover it with this. And by tomorrow it will be different. Very nice food.
What is the size of the plate?
I'll show you. And add in some water according to the thickness, which is not very thick. For instance, this one is a bit thick. So this one I mix in very little water.
How much water? Just
half liter. In addition, I bring sweet potato vines. Potato vines. Add to that. Sometimes
so you supplement with sweet potato vines?
Yes.
And what else?
And just water. They need a lot of water after taking this. That is
okay. So where do you get these yam leaves and sweet potato vines?
I have them around.
Okay.
Around, yeah. This is where I keep my manure. After some time, I get this one and take it to. We used it on the maize very well. Grow very well. It's I would say better than the DAP. It's DAP. DAP we use.
So you see the smart application of the fertilizer. Yes, please.
Yes, and this more or less goes to like a windrow. Is this they are using the droppings?
Yes,
that is a resource now for the field.
Very much.
The farming system, I think, isn't it? And this is exactly what is being reflected. There's basically no waste. It's just changing the position of
not wasted.
Yeah. Of course, now because now if the vines are here, and they will go through the manure back.
Yes.
Back to the
another form.
So the pig manure is also there.
No, the pigs will collect it from down there, but we have not yet started.
Yeah.
So what we get out, we just throw the other side. And sometimes we collect it there, and there is a collection somewhere by that small house.
And because Mr. Lasha he got the skills and the family got the skills from the what? The center. Did you see how the center is managing the poultry, the piggery, the goat, the cattle waste? It's all integrated. So now then the farmers can adapt and modify it according to their own what? Situations, not necessarily the other one.
And another good thing, they offer extension service. They come and visit us and advise.
Yeah.
And that's how we are moving with them properly.
Yeah.
We own 25 acres of land.
The center is how many acres? 25. The center where we came from. So you are right. No, that is you give a man.
Organic farming.
We talked about the pattern itself. But of course, if it would be a soil problem, would it be a micronutrient or a macronutrient deficiency?
That can lead to spread of what? Diseases. So tomatoes, and then also when you don't intend to stake, the tomato should rest on the what? On the mulch. There are two options: you mulch, and then the fruits land on the grass, and they are clean, or you stake it. So those are two options. But I think he has preferred the option of what? Mulching, and he says it's work in progress. So he intends to what? To spread the mulch all over. So I think he was inviting questions from us in case. The land uses, these are the major ones, in light of the nature of the ecosystem that we are dealing with. I think there is somewhere where the main canal for the water. Yeah. So this is a landscape that was buried under water. I don't know whether these are sulfur-rich soils. I'm talking about generally the wetland. We are here for general knowledge. What happens when you drain a wetland? There is decomposition of organic matter, which is accumulated under anaerobic conditions. So when this land use drives the farmer to localize the flow.
School lunch, we supported the construction of the school kitchen. Then the energy saving stove, we shall get to see there is a stove for the grains parents don't there is a serving point, we shall get to see, because this is a solid meal which is a bit labor intensive. Yeah, just to soak the maize and serve. All the pupils in this school have their school lunch here. The school lunch is made of whole grain of maize and beans. The boys were complaining last year we renovated one of the so we gave them the beds, mattress, and blanket. what I see during
has
the
taken
cleaning.
place. Yeah. So yeah, because now I imagine it might have already taken place. So the future seeds will have
This.
crosses. Yeah. So the timing is very important. So.
To plant 1 acre, we need 1 kilo. The yield is between 300 and 500, basing on the management practices. If you apply manure, you get better.
That's a research issue.
Yeah.
So how much to apply, and then the timing of application is just at the one spot application, or if you are splitting at what stages.
Yeah.
Yeah. Our teacher for school gardening
nice
has
to see
joined
all
us.
of you.
Thank you.
Some of you know me. Like the friend there. The garden teacher here. With the Amarantha, I see my colleague have been gambling, but the problem why we have this
What was here?
it is due to little. That's why you see that there is a little bit poor yield. But we are planning another garden there, which we are going to manage very well. You will see that one plant like this one can make a half a kilo.
Yeah.
Yes, because last time here we harvested over 360 kilograms of amaranth, this small area here. And this type
Maybe
is called
to add
the
on
golden
that,
what?
the major challenge with amaranth is planting. If
Planting.
you plant today,
Yeah.
right now, and it rains tomorrow, that is a loss, 100%.
100% a loss.
Why?
It's
Because
small seed.
the seeds themselves are tiny.
So when he says that they planted and it rained, that means the germinability was poor.
Yeah.
They must have reseeded. Chlorine. So they are promoting taking safe water. You will just get a drop and put in the water. Bana, wechibanga chidomolo chidalota mu obuntu bumeka. Bumeka? Ate nga kitundu. So this is the remains of a ferry. Before, items used to come from
Guys,
that area is too deep. It was the landing site.
there is even no Tom.
Don't do this.
The next place is very deep. So better keep distance.
Welcome to Namasagali. We are on the portion of the Victoria Nile that actually heads to Lake Chioga. You can zoom over there, that island there. After that, the water actually drains into Lake Victoria. What we are doing here, we have brought the students combining land use and management, soil science, integrated watershed at undergraduate and the postgraduate levels to highlight impacts of human activities on this kind of ecosystem. So what are we observing here? This old structure here was the old ferry that used to bring produce all the way from Bukedia and all those parts. From here, it would then join the Namasagali Railway for transportation to Kampala. We are also seeing a lot of fishing going on, a lot of sand mining. You can see the heaps of sand which is extracted from the river. These young men are the ones who are involved in sand mining. They dive into the water, they scoop sand until they make a trip. And for a full trip, they are paid somewhere between 80,000 to 100,000 to make a living. So what impacts do this create on the ecosystem? You can see traces of the vegetation. I think that is water hyacinth, and we hope that soon this will not be covered. if you look at the quality of this water, the clarity is quite low. There is too much green, indicating that there is organic. The contamination with all sorts of waste from the industries, from agricultural activities, from municipal wastewater treatment plants. So boat riding is the other important attribute. And just within here, over there, that is in Namasagali. That is Busitama campus, Namasagali, and then up the other side is the college itself, Namasagali College. This flat surface here is a clear sign of a riverbed, and actually in 2020-2021 this place was flooded up where those trees, where you can see those trees, for a whole year, indicating that water was trying to regain its territory, but because of the activities that are undermining the ecosystem, degradation is taking place, and the water is pushed the deepest levels. Over there you can see sugarcane production, pine, eucalyptus is now the new activities, and sugar factories are over there. They also generate a lot of waste that is threatening this ecosystem. So how do we then ensure that the activities around this ecosystem are consistent with sustainable use within the context of climate change mitigation and other processes? That's why we are here with the colleagues, Emmanuel Polot, our dear students. This normally happens every year to our final year students. It's unfortunate that whereas this was the opportunity to expose them to what is happening in the field, to trigger them to take action, this program is being phased out when that is land use and management, when issues of land degradation are high on the agenda of sustainable development. Thank you.